Today we'll be multiplying polynomials. We'll first multiply a monomial times a polynomial, then a binomial times a binomial, and then we'll look at multiplying special products and looking at the pattern. To begin with, we'll start with monomial times a polynomial. So to multiply a monomial by a polynomial, we use the distributive property. And when we're working with exponents, don't forget to add the exponents when multiplying terms with the same base. So go ahead and do numbers 1, 2, and 3. Try 4, 5, and 6. So now we're going to multiply a binomial times a binomial. And we're going to use the acronym FOIL, F-O-I-L. So the F stands for first, so we multiply the first terms together, A times C. The O stands for outer, then we multiply the outer terms, A times D. So in essence, we are distributing the A in the first binomial to the C and D in the second binomial. So A times C, A times D. The I stands for inner. So we're going to multiply the inner terms, B times C. And the L stands for last. We're going to multiply the last terms, B and D. So in essence, for the inner and last, we're distributing the B to the C and the D. So B times C and B times D. First, outer, inner, last. That's our method called FOIL. So let's try number 7 together. We're going to multiply the first terms. X times X is X squared. Then the outer. X times 7 is 7X. Then the inner. 6 times X is 6X. And 6 times 7 is 42. And we combine like terms. X squared plus 13X plus 42. First, outer, inner, last. Try number 8. All right, number 12, we have a binomial times a trinomial. So you can go ahead and distribute the 2f to all three terms and the -9 to all three terms and combine like terms. We can also use what we call the box method. So here I have 2 columns and 3 rows. I could have 2 rows and 3 columns, doesn't matter. And what I do here is I draw a box, and then I put each term. So the 2f and the minus 9 go here, and the 3f squared minus 5f plus 6 goes there. Now I'm going to just multiply the area of the boxes. So I have 6f to the third. Then I'm going to have a negative 10f squared. Then I'm going to have a different color, 12f. Here I have a positive 45f. And the f squared, negative 27f squared, and a negative 54. So when I combine like terms, I get 6f to the third, negative 37f squared, plus 57f minus 54. Now let's look at some special products. When we square a binomial, there's a pattern that we can memorize, and then we don't have to FOIL it. We have a plus b squared. When we have a plus b squared, that equals a squared plus 2ab plus b squared. That's the pattern. When we have a minus b squared, the pattern is a squared minus 2ab plus b squared. So if we memorize these patterns, it makes the FOILing and multiplying go faster. So here we have x plus 7 squared. So if we were to FOIL this, we'd say x plus 7 times x plus 7. That's x squared plus 7x plus 49. So we can see here that the first term, x in this case, is squared. The second term is 2 times ab. So if we multiply these together and double them, that's the second term. And if we square the last term, b squared, that'll give us our trinomial. So what we could think of this is we could think of the first term as a, which is x, and the second term as b is 7. And we can say a squared times plus 2 times ab. So 7 times x squared times 2, 14x, and then square the third term. So that's a little pattern we have there. So let's try that with number 14. Our a is w, and our b is 3. So it's a minus, so we're going to take this pattern. We're going to square the first term. We're going to multiply them together and double them. So that's 6w, and then we're going to square the last term. All right, so do we see the pattern here? This is squared, multiplied and doubled. Squared, squared, multiplied and doubled. Squared, squared, multiplied and doubled. So that's the square of a binomial. There's one more pattern. It's the product of a sum and difference. So we multiply a plus b times a minus b, we get a squared minus b squared. Let's look at this as an example. We have b times b is b squared minus 3b plus 3b minus 9. So b squared minus 9. So you can see here when we have two binomials, one's positive and one's negative, the middle term zeroes out. So we just have the square of the first and the last term. So here if I say a equals b and b equals 3, then b squared, square the first one, and square the last. Okay, the product of a sum and a difference, square the first minus the last one squared. See the pattern? When we have a positive and a negative, the middle term zeroes out.